Good morning. Today I will be showing you guys how to call data and work with data sets in RStudio. Okay, so first things first, let's start a new script. So to call a data set is pretty simple. First, you got to make sure your CSV file is in your working directory that you set. To call your data, you simply do read CSV. Wonderful, and then make sure you put it in parentheses, alright? Electric babies .csv. Wonderful. Make sure you have it in quotes. I almost forgot, you want to assign a name to it. So we'll call it Elebab, electric babies. Okay, put your little arrow, and that should appear on the right quadrant up here. Wonderful. So what this is, it got the CSV file, which is basically an Excel file that's really easy for RStudio to read, into a workable data set. So if you go here and double click Elebab, you'll be able to see what is in the data set. And as you can see, they have some numbers, they have some countries, so it's not exactly clean, but all the data is here. So in order to clean the data, I had previously prepared a bunch of code. So just for the purpose of this video, to make it easier for you, I'll explain exactly what each code does so you can copy it if you need. But here it is. Right here, this is what we originally did. The code actually has this part of it as well, which removes the double dots, it removes the NAs, and it removes the empty spaces. So if you go here, you'll see there's some double dots, and we don't want those. So this is the code that will do that for you. This next one, it just selects the variables that I do not want. Okay, country code, country name, time code, and time, those were variables that I was not interested in over here. So I just cut them out so it's not wasting time. Also, hospital beds per 1,000 people and exclusive breastfeeding, children under 6 months. Those were variables that just didn't have enough data. You see all that right here? And there's a lot of missing data. So I took those out as well. This just takes out the rest of the NAs. This code chunk just renames the variables to something a lot easier to work with. So instead of having to write this whole chunk, you just write electricity. Right, because over here the name of the variable is prevalence of moderate or severe food insecurity in the population SNITK MSFI CS crazy. And with this I can just call it electricity. And this I change it to this represents the mortality rate, my main dependent variable. This represents food imports. This represents prevalence of moderate or severe food, which is how hungry people are getting, and this represents health expenditure. And right here just selects the only variables that I want to work with. So after running all this, let's run it. We have our 3 years. So this should be our most clean version of Elebab 3, where it has 5 easy variables to work with and no missing data. Just keep in mind, this says 264, but there's really only 98 observations because they were taken out. You see 259 is missing because it had an NA, had an empty spot, so they just took the whole thing out. So don't trick yourself in thinking you have a lot of variables. Technically, this is not a lot of variables for a good analysis. Around 200, 250 is a good start, but just to keep in mind that this number does not represent the number of variables that are in this data set. After our data is clean, now we're able to start working with our data directly. Right here is how to write a linear model, regression, ordinary least squares. And if you punch it through here, you see it pops up on the right as Elemod. So this, when we enter Elemod, it'll just pump out our linear regression. And to see the linear regression, we're going to do the summary function with Elemod. So as you can see here, with the Summary of our linear regression. We see that hunger, food, and electricity are significantly related to infant mortality rate, and the strongest, it seems to be electricity. It has the strongest negative relationship. Next, we're going to check for multicollinearity, super simple. So first by making a correlation plot. So that brings us the plot over here into the plots pane. We can see the infant mortality, our main dependent variable. See, it's strongly related with hunger and electricity, just like what our model says. So we're going to ignore this because it's our dependent variable. But looking at food, hunger, health, we should see here, note that, look, hunger with food, they might have a correlation. Hunger with electricity, looks like it could be multicollinear. So this is an easy way to see what you want to check for multicollinearity. So the next test we will do, it's called a VIF test. It'll check for every independent variable if it's multicollinear with any of the other ones. So we did it for hunger, food, and electricity, because as you can see here, hunger and electricity, they're pretty strong. Food and hunger are pretty correlated as well. That makes sense. If there's no food coming into a country, there's likely that more people are being hungry. So we will check this here. 2, 3. And with the VIF test, we're just looking for anything above a 10. If anything is above a 10, then it's definitely multicollinear. They have major problems. In this case, we're just around the 1 or 2 area, so we should be fine when it comes to multicollinearity. Okay, just make sure we report that we did these tests in our final report. Next, we will do a plot for heteroskedasticity, just to see if our model is heteroskedastic at all. Run that, and it looks like it is. Like we learned, it has a fan-out pattern with the residuals, so there is a hint that it's heteroskedastic. And to get a good look at that graph, it looks like this. Okay, again, look at the code. And then another test we can do for heteroskedasticity is the Bruce-Pagan test. So here you just enter that. Go down here to our console. We see that it is definitely significant, that it is heteroskedastic. So a way we can deal with this to see if our p-values that we mentioned up here, because it's heteroskedastic, it means that we ought not to trust these p-values as much. Therefore, when we run robust standard errors, it's a way we can do a regression where the p-values are a little more trustworthy. Okay, so we make a new model, and this is the code to make a robust linear model, similar to the first one, but then you just put SE types data and make sure it's underscore robust. Like that. Awesome, and you see it shows up right here on the right. And do a summary of that. Wonderful. Now when we do this, the stars don't show up because it's a different way of running a regression, but we can still see if it's significant by looking at our p-values. Okay, so we can see that this is definitely significant, electricity. We can see that this one is not significant. We can see that hunger is definitely significant, and we can see that health is not significant. So now we can see it's hunger and electricity, whereas up here in our original model, food was also significant, but with the robust standard errors it became insignificant. And next we will plot to see the relationship between hunger and infant mortality. So we see there's definitely a positive relationship, that the more hungry a country is, the less likely an infant under 6 months, I think, is going to survive. Next, we will check to see if our error term is normally distributed. So if we go here, we click there and there. Wonderful. So looking at this, it looks pretty normal. Okay, it's not skewed to any direction. Next, we'll look at the results of the Shapiro-Wilk, Kolmogorov, and the Anderson test. We see that all three of these tests, they came out as statistically significant. So that means that our errors are not normally distributed, which is bad. It breaks the assumption. So make sure you report that in the final report if this is an issue in your analysis. That's all I have for you today. I hope this video was able to help you understand at least how to pull out data and look at how to clean it up. If you're wondering which packages I used for my analysis, you see all these up here. Thank you for watching and happy coding!